Hello and welcome to electrolytic cells. So this is a question that you're probably already familiar with, but let's go over it again because it covers two key elements, I guess. It covers the fuel cells from Unit 4 and also covers electrolysis from Unit 3. So whenever I see a question that has something, you kind of look through the question itself. So I can see down here straight away that it's going to be something to do with redox. So I'm going to look at oxidation and reduction. So I want to see what else will have um, some information for me. So I want to really know if it's a galvanic cell or an electrolytic cell because that'll make a big difference. And I guess you've just got to remember that an hydrogen fuel cell is electrolytic. The other key piece of information here is that it's an acidic fuel cell. That makes a big difference later on. We can see we've got our anode here, and you should know that that's where oxidation occurs. And we've got our cathode, and that's where reduction occurs. You're also given this bit of information here. So these are your starting reactants. So that's important because they have to stay on the left-hand side. So straight away, I can go down here with my anode. I know my anode is oxidation, and I know I'm going to start with hydrogen gas. I can go to my cathode, and I know I'm going to start with oxygen gas. Now you're going to use your data booklet. So if we have a look at our data booklet here, we want H2 and we want oxygen gas. So what we want to look for though is the one that has the acid. So that was the important thing. So if I look for my hydrogen, I've got two. I've got this one here. It's a terrible color. Okay. And we have the one that's a little bit higher up as well. Okay, now the difference between the two is this one is the acid. Okay, so this is the one here. I need. Okay, so this one here is going to be the one that I use. Because if we have a look, it's got acid in it. Now that's written in the reverse of what I want. And that makes sense because these are all written as reduction. And what we want is the oxidation at the end. So I'm just going to rewrite that, but in the reverse. So go back to here and make sure you use your equilibrium atoms. I've got two of these, two electrons. Okay. Now go back to my data booklet and I'm looking for oxygen. And I'm looking for the oxygen that has hydrogen ions in it. So I've got this one here, but that one has hydroxyl. So to go a little bit further down, and I see that this one here has hydrogen ions. So this is going to be the one here that I'm going to use as my cathode reaction. So I go back to my question. And I write it out exactly as it is from the data booklet. Just make sure I've got them right. Okay, good. So there we go. That's that part of it done. If I scroll down a little bit here, identify product Z. So there's a couple of ways you could do it. You could look at those reactions above and balance them. So if I double the first one, because I need 4 electrons, and I've double the top one. So I have 4 hydrogen ions. I've cancelled out my electrons. And you can see there that that cancels out. What am I left with? I'm left with water. And with all these fuel cells, hydrogen fuel cells, that's what you're producing. That's always the product, water. Okay. Now this is a little bit tricky. So when you have compare, you have to be very, very careful about the question itself. Compare always has three: similarity, difference, and significance. So the question itself is looking at the movement of electrons and hydrogen ions. So we don't care about the oxygen at all. It's just the electrons and hydrogen ions. And if we look at them, because this is being oxidized, it means these electrons are traveling here. And the hydrogen is also traveling there. Because these two have to meet in order to form water. They have to react. So they're both moving towards each other. So what we can write here is both H plus and E naught move from anode to cathode. Okay, because that keyword movement. Now, what is the difference between them? So the difference between them is the electrons will go through the path of least resistance, which in this case is an external wire. Hydrogen has no choice but to go through this proton exchange membrane here. So we can write that as well. Electrons move through external wire. H plus ions move through proton exchange membrane. So you can see here that we're not explaining why, but we do kind of need to in the significance. The significance is perhaps why are they doing this? Why are they moving from the anode to the cathode? And the significance of that is it generates electricity. And that's what we want with our galvanic and electrolytic cells. So we want an electropotential difference. Okay? So E naught values are what we call EMF, which is electromotive force. Which is another name for electron potential difference. What that basically means is you need two different E naught values. If they're both the same E naught values, you're not going to have any electrons moving at all. It's like having copper and copper. It's not going to work unless you actually put a force into it to make it work. So you need something that is different in order for this to work. So the movement of electrons creates an electropotential difference. Okay, and that's how we answer that question. With all these redox questions, you're probably going to have to do half reactions. And all your half reactions, 90% of them are in this table here. So you need to go have a look at this table and use it very, very carefully and find the reactions from this, the half reactions.